Okay guys, so today I'll be making a video of a tutorial to teach you how to solve the method of false position or regular falsi. Now this is a very simple method, and the sole purpose of this method is to find the roots of equations. I'll start simply by telling the formula to solve the equation, and the formula is to find the value of x. Now how is that value of x going to help us find the roots? I'll just explain. Starting by the formula is simple. X2 equals x0 minus x1 minus x0 upon f of x1 minus f of x0 multiplied by f of x0. Now we have a question over here that find real root of equation x log base 10 x equals 1.2. Let's start with the solution. I start the solution by writing f of x equals to x log base 10 x minus 1.2. Now I need to first find that where does my root really lies, and for that I have taken some random values. For example, I've taken my first initial guess as 1, as x is equal to 1, and I find that when I put x is equals to 1, I have a value that is negative. Then I take another guess, which is x equals to 2, and I put that in the equation, this equation, and I get a value that is negative. Now we know that the root always lies between a positive and a negative value of y. So I put in another value, that is x equals to 3, and when I put that value, I get a value of f of 3, that is y equals to a positive value. Now I have two values of x that are giving me a positive and a negative value in y. So I know that my root lies between the value of x and x equals to 2 and x equals to 3. Now we start solving the question, that is taking x0 as 2 and my x1 equals to 3. Now I'm gonna plug these values in this equation, but before that I find the value, exact value. When I put 2, I get a value of negative 0.59794, and when I put the value of x1, that is 3, I get a value positive 0.23136. Now as I have these values, all I need is to plug these values back in this equation so that I can find my x2. Now what we are doing here is we are trying to get more nearer and nearer to the real value of the root. So when I put the values of these in my formula, I get my value of x2 as 2.72102. Now see how our last value of x was 2, and it jumped from 2 to 2.72107. Now when I put in the value of x2, I get a negative value. Now this negative value, if I compare that with my previous negative value, this value is much larger. That means it's actually closer to 0. Now when this is closer to 0, that means my answer is closer to this one, this value. So what I do is I take this value that I got x2, and then I solve between 2.72102 and 3, because I know that my root lies between these two values. Now I take my x0 as this, that is 2.72102, and my x1 as 3. I find the value of x1, f of x1, that is y equals to 0.23136 as my y value, and I then put it back in this formula, the journal formula, to find the value of x3. Now when I put in that value, I get a value for x3 equals to 2.74021. Now see how this value is much more closer to this value, so that means my root lies nearer to this value. So I'll do this iteration again. we will repeat these tests for x4 and x5 just as the same we did this over here. And then I found out that my x4 was equal to 2.74024 and my x5 was equal to 2.74063. Now notice how my x value is very near to each other. That means that I'm very close to my root because the value is not changing significantly now. As the question demanded that I give the answer to correct to 4 decimal places, I know that my x5 equals to 2.74063, so my root answer would be 2.7406. Now when I plug this value in this equation, I will get a value that is really close to y, the value of f of x. This is how we find the root in a regular falsi or false position method. I hope you understood it very well. Thank you so much.